This video provides detailed answers to questions from the Cambridge IGCSE Paper 2 Multiple Choice, October-November 2024 exam. I hope you find it useful in helping you prepare for future exams. In addition, on this channel, I have prepared lessons on each subject. Happy studying! Thanks in advance for watching this video. If you like it, please like it, subscribe to the channel and activate the bell. This is very important for the continuity of this channel. Question 1. A student uses a meter ruler to measure the length of a sheet of paper. Which measurement is shown to the nearest millimeter? The least count of an instrument is the smallest measurement that can be taken using an instrument. In other words, it is the smallest change an instrument can measure. For example, the ruler can measure a minimum of 1 millimeter in length. Therefore, ruler least count is 1, so the nearest value will be 0.293 meters. Question 2. A rocket travels with an average speed of 6 km per second for 2 minutes. What is the distance traveled by the rocket? To calculate average speed, we need the distance and time. To convert time to a single unit, multiply the minutes by 60 to get seconds. Now we can find the distance traveled by multiplying the average speed by the time taken. Question 3. The diagram shows the vertical forces acting on a ball as it falls vertically through the air. The ball does not reach terminal velocity. Which row describes what happens to the resultant force on the ball and what happens to the acceleration of the ball as it falls through the air? As the ball falls, its speed increases, leading to greater air resistance. The net force on the ball is the weight minus the air resistance, acting downward. Since air resistance opposes motion, the net force decreases, causing the ball's acceleration to decrease by Newton's second law. Question 4. A coconut falls from a palm tree. At X, it has just started falling. Y is the point just before it hits the ground. What is the acceleration of the coconut at X? To solve this question, you must know that the acceleration due to gravity is constant near the surface of the Earth, regardless of the speed or position of the object. The acceleration of the coconut in y is equal to the acceleration due to gravity. Therefore, the acceleration in y is the same as in x. Question 5. A car is driven round a bend in the road at a constant speed. What is the direction of the resultant force on the car when it is going round the bend? The resultant force on the car while turning a corner is perpendicular to its motion and directed inward. This centripetal force is necessary to keep the car on its curved path, pulling it toward the center of the curve. Question 6. The diagram shows a drawbridge that is attached to a wall by a hinge at one end and a cable at the other. The weight of the drawbridge and the tension in the cable are represented by the labeled arrows in the diagram. There is a third force at the hinge, which is not shown. The drawbridge is in equilibrium. Which arrows shows a possible direction for the force at the hinge? The drawbridge is in equilibrium, meaning the sum of all forces acting on it is zero. A third force at the hinge, which isn't shown, can be determined by completing the equilibrium polygon of forces to ensure the zero vector sum. Question 7. Which equation gives the momentum change of an object? The change in the object's momentum is force multiplied by time. Question 8. Which statement about the use of nuclear fuel as an energy resource is correct? This energy source can be produced by nuclear fission. Question 9. The diagram shows an object of mass m being projected with speed v from a point P to a point Q on top of a cliff height h. The object does work W against air resistance as it travels from P to Q. What is the kinetic energy of the object when it reaches point Q? Mechanical energy is the sum of kinetic energy and potential energy. At point P, the mechanical energy is solely kinetic since the object is at ground level, resulting in no potential energy. In the absence of air resistance, the mechanical energy at P would equal that at Q, demonstrating the conservation of mechanical energy. However, because the object works against air resistance while moving from P to Q, the loss of mechanical energy due to air resistance equals the change in mechanical energy. Question 10. The diagram shows a Sankey diagram for an electric drill. What is the total wasted energy shown by the diagram? A Sankey diagram is a visualization tool that illustrates energy flows in a system using arrows. The width of each arrow reflects the amount of energy transferred. The left side shows the total energy input, while the straight arrow pointing right indicates the useful energy output. Arrows that diverge represent wasted energy. To calculate wasted energy, use the formula wasted energy equals total input energy minus useful energy. Question 11. An elephant of weight 45,000 newtons stands with all 4 feet on the floor. The average pressure on the floor due to the elephant foot in contact with it is 34,000 pascals. What is the area of each foot of the elephant? Pressure is calculated using the formula pressure equals force divided by area. To find the area, we rearrange it to area equals force divided by pressure. With the elephant weighing 45 kilonewtons and exerting an average pressure of 34 kilopascal, we can determine the total area. Dividing that area by 4 gives the area for each foot. Question 12. Some air is trapped inside a metal container with a tightly fitting lid. The container is heated strongly behind a safety screen. The lid is blown off by the increased pressure of the air inside the container? What causes the increase in pressure of the air inside the container? As temperature rises, gas molecules gain kinetic energy and move faster, leading to more frequent collisions with the container walls, resulting in increased pressure. Question 13. A very hot mug of coffee is near a large unheated swimming pool holding 2 times 10 to the power of 6 kilograms of water. Which statement is correct? The internal energy of a system is proportional to the temperature. Therefore, if the temperature decreases, the internal energy also decreases. Question 14. A student measures the mass of water in an open container over 2 hours. The container is kept in a warm room. The results are in the table. Why does the mass of the water change? The most likely reason for the loss of water is evaporation. Evaporation is the process by which a liquid changes into a gas. Evaporation occurs when a liquid slowly turns into a gas below its boiling point. Question 15. A 1 kilogram block of aluminum requires more thermal energy to raise its temperature by 1 Celsius degrees than a 1 kilogram block of copper requires. Why is this? A 1 kilogram block of aluminum requires more thermal energy to raise its temperature by 1 Celsius degrees than a 1 kilogram block of copper, because aluminum has a higher specific heat capacity than copper, meaning it takes more energy to increase the temperature of a given mass of aluminum by a certain amount compared to copper. Question 16. A block of ice is at temperature of minus 100 Celsius degrees. Energy is supplied at a constant rate. The graph shows how its temperature changes. At which point have the ice completely changed in state to water and all the water completely changed state to steam? When a block of ice at minus 100 Celsius degrees is heated, it undergoes several phase changes until it transforms into steam. Initially, as heat is added, the temperature of the ice rises steadily until it reaches 0 Celsius degrees, absorbing heat at a specific rate. Upon reaching 0 Celsius degrees, the ice starts to melt, marking a phase change from solid to liquid. During this melting phase, the latent heat of fusion is absorbed, but the temperature remains constant until all the ice has melted. Once the ice has completely melted, the temperature of the resulting liquid water increases until it reaches the boiling point of 100 Celsius degrees. At this point, another phase change occurs as the water turns into steam. Again, the temperature remains constant during this process while the latent heat of vaporization is absorbed. The process concludes when all the water has turned into steam, and any additional heat will then increase the temperature of the steam. Question 17. Water waves are reflected at a plane surface. Which property of the waves is changed by the reflection? Reflection occurs when a wave bounces back, changing direction while returning to its original medium. In this process, the wave's frequency and wavelength remain unchanged. Question 18. A light ray is passed through air, glass, and water. At which point does the light speed decrease? A ray of light will slow down as it passes from air to glass and as it passes from air to water because light slows down as it enters a denser medium with a higher refractive index, causing it to change direction slightly and bend toward the normal. So, when light passes from air to glass, it will be deflected more than when it passes from air to water, and the speed of light decreases at points W and Y. Question 19. Plain water waves approach a narrow gap in a barrier. Which diagram shows the diffraction pattern that would occur? When a wave diffracts, its wavelength, frequency, and speed remain the same. Diffraction happens when the wavelength of the wave is comparable to the size of the obstacle. A wide gap produces a small amount of spreading at the edges, whereas a gap of similar size to the wavelength produces considerable spreading of the wavefront. The amplitude of the wave is less because the barrier on either side of the gap absorbs wave energy. Question 20. A ray of light enters a transparent plastic wedge from air and is incident on the lower surface at the critical angle as shown. The angle of incidence is I, the angle of refraction is R, and the critical angle is C, in which ray diagram are the angles labeled correctly. The angles of incidence, reflection, and refraction are measured relative to the normal line. Question 21. An object is placed 20 centimeters in front of a thin converging lens. The scale diagram shows how the lens forms a real inverted image. Which row gives the focal length of the lens and the distance of the image from the lens? To find the focal length, we will use the lens formula, but first we must use the scale given in this question to find the distance of the object and the distance of the image from the lens. The object distance is 20 centimeters, and the image distance is minus 5 centimeters. The negative sign indicates that the image is formed on the opposite side of the lens. Substituting the known values into the formula, we obtain the focal length of the lens. Question 22. Radio waves are electromagnetic waves. What is the wavelength of a radio wave of a frequency 2 times 10 to the power of 5 Hz? The wavelength of the wave is equal to the speed of the wave divided by the frequency. Question 23. A candle flame is placed in front of a loudspeaker. The loudspeaker produces a sound wave that causes air particles to vibrate. The vibrating air particles make the candle flame vibrate in the same direction as the air particles. Which row shows the direction of vibration of the candle flame and the nature of sound waves? Sound waves are classified as longitudinal waves where the vibrations of particles occur parallel to the direction of wave propagation. When a loudspeaker produces sound, it causes the air particles in front of it to vibrate back and forth, creating pressure fluctuations that travel through the air as sound waves. As the sound waves reach the candle flame, the air particles near it also vibrate, causing the flame to oscillate in the same direction, making it appear to flicker visibly. Question 24. The diagram shows part of the magnetic field around a strong magnet. In which position does a magnet pole experience the strongest force? The magnetic field is always strongest at the poles of a magnet, where the field lines are most concentrated. Since position A on the diagram shows the closest field lines, it represents the area with the strongest magnetic force. Question 25. There is a current of 0.6 amperes in a closed circuit. How much charge passes a point in the circuit in 2.5 minutes? Charge is the product of current and time. 2.5 minutes are 150 seconds. Question 26. Which two physical quantities have the unit joules per coulomb? The unit for electromotive force is volt, and volt is given as the ratio of work done on a unit electric charge to enable a unit electric charge to move across the circuit. Question 27. A copper wire is placed in an electrical circuit and its resistance is measured. The wire is then placed with a second copper wire with twice the length and a quarter of the diameter. What is the ratio of the resistance for the two wires? The equation that represents the impedance of the resistance of a cylindrical conductor on the variables affecting it takes into account the length of the wire, the cross-sectional area, and the resistivity of the material. When substituting the radius with the diameter, we note that the diameter is twice the radius. After performing some algebraic manipulation, we can derive the expression for resistance in terms of diameter. As the diameter and length of the wire change, the resistance also changes. If the length of the wire is doubled and the diameter is reduced by a quarter, we can determine the new resistance. Finally, we need to solve for the ratio between the two resistances. Question 28. Which circuit contains a diode connected in series with a fixed resistor? A fixed resistor has a resistance value that doesn't change. The resistance of the variable resistor can be changed by the user. It's also known as a potentiometer. Question 29. In the circuit shown, resistor X has twice the resistance of resistor Y. Which statement about the circuit is correct? A parallel circuit is an electrical circuit that has multiple paths for current to flow. The voltage is the same across each component in the circuit, but the sum of the currents in each path equals the total current flowing from the source. Question 30. A 4-ohm resistor and an 8-ohm resistor are connected in series with the power supply. A voltmeter connected across the 8-ohm resistor reads 36 volts. What is the voltmeter reading when it's connected across the 4-ohm resistor? A series circuit is an electrical circuit in which all components are connected in a single path. This means that the current is the same through all components, but the potential difference across each component can vary. To calculate the voltage drop across a resistor in a series circuit, we can use Ohm's law. According to Ohm's law, the potential difference is equal to the resistance multiplied by the current. To find the voltage drop across the first resistor, we solve Ohm's equation for that resistor and then substitute the current values into Ohm's equation for the second resistor. Question 31. A metal rod is placed in a magnetic field so that it is perpendicular to the field as shown. In which direction is the rod moved so that there is an induced current from Y to X? Whenever a current-carrying conductor lays in a magnetic field, a mechanical force is applied on the conductor to push it away from the field, which is the case with electric motors. Fleming's left-hand rule can be used to find the direction of this current. Whenever a conductor moves in a magnetic field, a current is induced in it, which is the case with electric generators. The direction of this current can be defined by Fleming's right-hand rule. Question 32. The diagram shows a basic electric motor. What are the names of the features? The features are coil, brushes, and commutator. Question 33. Two transformers, P and Q, each have 2000 turns on their primary coils and 1000 turns on their secondary coils. Both transformers are 100% efficient. The secondary of transformer P is connected to the primary of transformer Q. Q provides a motor with a current of 0.2 amp. What is the current being supplied to the primary of transformer P? Let's take a closer look at transformer P. It has 2000 turns in its primary coil and 100 turns in its secondary coil. We can use the transformer's turns ratio to determine the relationship between the primary current and the secondary current. Since the number of turns in the primary coil is greater than that in the secondary coil, transformer P is classified as a step-down transformer. This means it reduces the voltage from the primary to the secondary coil, while the secondary current will be greater than the primary current. To understand this relationship, we can note that with a turn ratio of 2 turns in the primary for every 1 turn in the secondary, the secondary current will be twice that of the primary current. Now the secondary of transformer P is connected to the primary of transformer Q. The secondary current in transformer P becomes the primary current in transformer Q, which has a secondary current of 0.2 amp. We can again use the turns ratio for transformer Q to find the relationship between its primary and secondary currents. In transformer Q, the secondary current is 4 times greater than the primary current in transformer P. Since the secondary current in transformer Q is 0.2 amp, the primary current in transformer P would be 0.05 amp. Question 34. Alpha particles are directed at a metal foil. Most of the particles pass through the foil with little change in direction. A small portion of the particles are scattered back through large angles. What does this evidence suggest about the structure of an atom? Since most alpha particles pass through the foil with little deflection, this indicates that most of the volume of an atom is empty space. The small proportion of alpha particles that are scattered back at large angles suggests that there is a small, dense region within the atom where a strong positive charge is concentrated, causing the positively charged alpha particles to be repelled. This small, dense, positively charged region is called the nucleus. Question 35. Which statement correctly compares the properties of alpha particles and beta particles? Beta particles can penetrate further through matter than alpha particles due to their smaller size. Although less penetrating, alpha particles have a higher ionizing power because of their larger mass and charge. Question 36. Which statement about alpha decay is correct? In alpha decay, an alpha particle is emitted consisting of 2 protons and 2 neutrons, a helium nucleus, causing the atomic number to decrease by 2 and the mass number to decrease by 4. Therefore, it becomes the nucleus of a different element. Question 37. An explosion in a nuclear reactor spreads the isotope cesium across a large area. After 90 years have passed, the quantity of cesium present is 12.5% of its original level. What is the half-life of cesium-137? After one half-life, the amount of cesium remaining will be half of the original amount. After another half-life, the remaining amount will be half of what it was just after the first half-life. This process continues with the amount of cesium having with each subsequent half-life. Since 90 years is approximately 3 half-lives, we can conclude that the half-life of cesium is about 30 years. Question 38. Which type of object rotates around the Sun with an elliptical orbit? Objects that rotate around the Sun in an elliptical orbit are planets, asteroids, and comets. Question 39. Which statement about the Sun is correct? Solar energy is created by nuclear fission that takes place in the Sun's core. Question 40. To determine the value of the Hubble constant, an astronomer measures the distance of a galaxy from the Earth as 2.5 times 10 to the power of minus 21 kilometer. She also measures the speed of the recession of the galaxy from the Earth as 5.2 times 10 to the power of 3 kilometers per second. From these data, what is the value of the Hubble constant? Hubble's law states that the Hubble constant is equal to the speed of an object moving away from an observer. This speed is also known as the recession speed, divided by the distance between the object and Earth.